A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
You know, Corn, this whole show runs on GPU compute, and we wouldn't be here without Modal.
Seriously. And that's what powers all our text-to-speech. Everything you're hearing right now.
They're an AI infrastructure platform. Developers use them to run GPU workloads in the cloud with zero infrastructure headaches.
If you're building anything with AI, check them out. Modal.com. So, today's prompt from Daniel has us diving deep into LangGraph. Herman Poppleberry, perfect timing, because, honestly, the conversation around agent frameworks has gotten really noisy lately. Everyone's got an opinion, but few people are digging into what these systems actually do under the hood. LangGraph's become this default choice, but a lot of tutorials treat it like a magic black box, which, as we know, is usually a sign that something interesting and complicated is happening inside. So let's open it up. What is LangGraph at its core that makes it different from just chaining a bunch of LangChain calls together?
It's a fundamental shift in execution model. Think of traditional LangChain, or most early agent frameworks, as a straight line. You have an input, it goes through some steps, maybe branches once, and you get an output. It's essentially a directed acyclic graph, a DAG. LangGraph, as the name implies, introduces cycles. It allows you to build a graph of nodes where you can loop back, iterate, and maintain state across multiple passes through that loop.
That sounds simple, but the implications are massive. It's the difference between a script that runs once and a persistent process that can reason, correct itself, and build on previous work.
That's the key distinction. It went from a library for stitching together prompts to an engine for running stateful, long-running applications. The state object is the star of the show. It's this shared memory space that every node in your graph can read from and write to. Your LLM call, your tool, your conditional logic, they all operate on this common state which persists across each step of the graph's execution.
So it's not just passing an output from step A to step B. It's more like a shared workspace that everyone is collaborating on, and you can keep revisiting that workspace, adding to it until some condition says you're done.
Right? And this is why it exploded in popularity for building real agents. If you want an agent that can do research, it's not just search, summarize, done. It's search, analyze the results, decide if you need to search again with better terms, synthesize, check confidence, maybe search another source, and finally format. That requires loops and a memory of what you've already found. LangGraph formalizes that pattern.
By the way, today's episode is powered by DeepSeek v3.2. Alright, so history lesson. This didn't come out of nowhere.
It came out of a very specific pain point within LangChain itself. Back in mid-2024, as people started building more sophisticated agents, they kept hacking state management on top of the existing chain constructs. It was messy. The LangChain team essentially looked at all those hacks and built a first-class framework around them. The 0.2 release established the core patterns, and then the big one, 0.3, dropped this past January.
January 2026, for those keeping score at home.
Yes, and that 0.3 release is crucial because it addressed some of the early rough edges, particularly around state serialization and debugging. Suddenly, you could much more easily save an agent's entire state to disk, pause it, resume it later, or introspect what happened at each node. That's a game changer for production systems.
Now that we understand the architecture, let's look at how this actually plays out in implementation. If I'm a developer looking at this, what am I actually building? What are the nouns and verbs?
You're building a graph composed of nodes and edges. A node is typically a function. It could be a function that calls an LLM, one that calls a tool like a web search, one that performs some data validation, or just plain Python logic. Each node receives the shared state, does something, and returns an update to that state.
And the edges are the pathways between nodes.
They define the flow. Some edges are unconditional, always go from node A to node B, but the powerful ones are conditional. Based on something in the state, like the LLM's decision, you can route to different nodes. This is how you build decision trees. And critically, you can have an edge that goes from a node back to itself or back to a previous node, creating a cycle. That's the loop.
So you define this graph structure, you give it a starting state, and you tell it to run until it hits an endpoint node.
Or until it hits a cycle limit, which is an important safety valve you should always set. You don't want an agent getting stuck in an infinite loop because of a reasoning error. But yeah, you kick it off, and it walks the graph, updating the state at each step. The output is usually the final state after the run completes.
This is starting to paint a picture of where the complexity lies. It's not just the graph design, it's the state design. What goes into that state object?
That's the million-dollar question, and it's where most people stumble early on. You have to design your state schema up front. What information needs to persist across the entire workflow? Usually, you have things like the original user query, a growing list of intermediate results or findings, the conversation history if it's a chat agent, a scratch pad for the agent's internal reasoning, and maybe some flags like task complete or confidence score.
And every node has to be aware of this schema. If a node expects a field called documents, and you forget to put it in the initial state, things break.
Precisely. The state is like a shared contract. All your nodes are agreeing to work with this specific dictionary structure. LangGraph now has better tooling to define this as a pedantic model, which helps with validation, but it's still a conceptual burden you don't have with a simple linear chain.
This brings us to the practical implications. How does this compare to other frameworks? Let's talk implementation patterns. If I'm building, say, a customer support triage agent, what does a LangGraph look like versus me just writing a Python script with some if statements?
The LangGraph approach forces you to separate concerns cleanly. You'd probably have a node that classifies the intent of the query. That node updates the state with something like intent, billing issues. A conditional edge then reads that and routes to a handle billing node. That node might call a tool to fetch the user's account details, then call an LLM to draft a response, then update the state with that draft. Another node might check the draft against policy guidelines. If it passes, it goes to a finalized node. If it fails, it might loop back to the handle billing node with instructions to try again.
Versus a script, which would likely be a monolithic block of code where the classification, tool calling, and validation are all intermingled.
The script is harder to debug, harder to modify, and nearly impossible to pause and resume. With LangGraph, each node is a testable unit. You can see the exact state transformation at each step in a debugger. And because the state is serializable, you can literally save the entire agent's context to a database if a human needs to take over, and then resume hours later.
That human in the loop pattern is a big one. You can have a node that doesn't call an LLM or a tool, but instead sends the state to a human interface and waits for a signal to proceed.
Which is incredibly powerful for production. You can have an agent do 95% of the work, then pause for human approval on a sensitive action, like issuing a refund over a certain amount. The workflow stays intact.
Alright, so that's the how. Let's get to the when, and more importantly, the when not. When should I reach for LangGraph, and when is it overkill?
The strongest case for LangGraph is any agentic workflow that requires cycles, complex branching, or needs to maintain memory across more than 3 or 4 steps. If you're building a research agent, a coding agent that writes tests and then debugs its own code, a negotiation bot, anything that involves iteration, that's LangGraph territory.
And the when not.
If your task is a simple linear pipeline, take a query, search the web, summarize the top result. Vanilla LangChain, or even just the OpenAI API with function calling, is simpler and faster to implement. The overhead of defining a state schema and a graph for 3 linear steps isn't worth it. Also, if you're in a highly constrained environment where you cannot have any persistent state or the overhead of the library is too high, you might look elsewhere.
That brings us to the competition. How does LangGraph stack up against something like Crew AI or AutoGen?
Crew AI sits at a higher level of abstraction. It's more opinionated. It gives you ready-made concepts like agents, tasks, and processes. It's fantastic for quickly prototyping a crew of specialized agents. But that opinionation can become a constraint. If you need fine-grained control over the state object, or you need a weird, non-standard loop, you might fight the framework.
So Crew AI is like driving an automatic transmission. It handles a lot for you, but you can't manually downshift. LangGraph is the manual gearbox.
That's a decent analogy. AutoGen, on the other hand, is incredibly flexible, built around a message-passing paradigm between agents. It can model incredibly complex, multi-agent conversations, but it gives you less structure out of the box for managing the overall workflow state. You have to build more scaffolding yourself. LangGraph provides a more rigid, but often more productive, structure for a single complex agent's internal workflow.
And where does the new kid on the block, Microsoft's AutoGen Studio, fit in?
AutoGen Studio is trying to do for AutoGen what LangGraph did for LangChain, provide a more structured graph-based way to define those multi-agent workflows. It's still early, but it shows the industry is converging on this graph-based orchestration model. It's becoming the paradigm.
Let's talk pitfalls. You mentioned state schema design. What are the other common ways people shoot themselves in the foot with LangGraph?
The biggest one after state design is mismanaging the state size. It's tempting to just dump the entire conversation history, plus all retrieved documents, plus all intermediate reasoning, into the state. But the state is passed to every node and often to the LLM within those nodes. You can blow through context windows incredibly fast, slow everything down, and increase cost.
So you need a state hygiene strategy. What does that look like?
You need to be selective. Summarize long passages before adding them to state. Prune old messages from history, maybe keeping only a summary of earlier interactions. Don't store raw HTML from 10 web pages, store the extracted text and then a condensed version. The state should be a distilled working memory, not a dump of all raw data.
Another pitfall.
Not setting cycle limits. Always define a maximum number of cycles for any loop. An agent can get confused and start going in circles, racking up huge API costs. You need a hard stop. Also, poor error handling within nodes. If a tool call in one node fails, you need to handle that gracefully in the graph, maybe routing to a remediation node instead of letting the whole graph crash.
And I'd imagine documentation, or the lack thereof, is a pain point for teams trying to maintain these graphs.
A LangGraph is not self-documenting. You need to document not just what each node does, but how the state evolves through the graph. A diagram is almost mandatory for anything non-trivial. Teams that skip this end up with spaghetti graph that nobody understands 6 months later.
So, practical takeaways. If someone's listening and wants to try this out, where should they start?
Start with the official LangGraph tutorials, but go straight to the 0.3 examples. Ignore the older stuff, the patterns have evolved. Build something simple with a clear loop, like an agent that reformats a piece of code until a linter gives it a perfect score. That'll teach you state, cycles, and conditional routing.
And for production?
For production, invest time in designing your state schema like you design a database schema. Implement thorough logging of the state after each node. It's a lifesaver for debugging. And strongly consider using the checkpointing system introduced in 0.3 for any long-running agent so you can resume from failures.
This feels like one of those technologies that's not just a library, but a shift in how we think about building with LLMs. It moves us from single-turn prompt and pray to multi-turn stateful applications.
That's the key insight. We've been using LLMs as fancy stateless functions. LangGraph and frameworks like it are how we turn them into stateful, persistent processes. It's the foundation for agents that can actually accomplish complex tasks over time. If you're interested in this agent architecture shift, we did a related deep dive in episode 1220 on APIs for agents, which is a great companion to this.
And of course, for more on memory and state, episode 846, Beyond the Vector, gets into the broader challenges this is solving.
The landscape is moving fast, but the principles of clear state management and robust orchestration are going to be foundational. LangGraph has its quirks, but it's currently the most practical way to implement those principles in Python.
So to wrap up, the big picture is this. If you need a simple chain, don't overcomplicate it. But if you're building an agent that thinks, iterates, and remembers, you're probably building a graph. And LangGraph is a solid, if sometimes complex, place to start.
Thanks as always to our producer Hilbert Flemingtop. And big thanks to Modal for providing the GPU credits that power this show.
If you're enjoying these deep dives, a quick review on your podcast app helps us reach new listeners.
This has been My Weird Prompts. We'll catch you next time.
This episode was generated using Gemini Flash 3. text-to-speech engine was Chatterbox.
Thanks for listening to our show, my weird prompts, where our thoughts go from slow takes